Great to be here. Thank you, Jules, for hosting us. Great to be here at Databricks. So yeah, I'm going to talk about networked AI agents in decentralized architecture, NANDA for short, also name of my sister. What is Agentic Web? I think this audience is very savvy, but it's good to remember that everybody's thinking about the mainframe era of AI. Big cloud, highly centralized data, highly centralized compute, $100 million salaries, nuclear power plants, and so on. But we think that's kind of a bit of a craziness because very quickly we want to move to edge AI with PCs and laptops that can run models on the edge. And that's going to just turn the whole world upside down. And that could happen in 2 years or 1 year or even 6 months because you can already run many of these models on edge devices. In the meantime, a lot of players are kind of dabbling with agents in the intranet. It hasn't really taken off, but there's a lot of activity that's going on, which is the intranet of agentic web, agentic AI. But intranet to the internet is going to be in a pretty big shift. But the internet was about connecting machines. The World Wide Web was about connecting people, and Nanda is about connecting agents. So, beyond the enterprise use case, we want you to start thinking about billions, maybe trillions of agents. And in the 90s, everybody was thinking about building. Again, in the mid 90s, folks thought that the best way to exploit the internet is actually start building solutions inside companies, inside enterprise use cases. But what was happening is that the adoption in the consumer world was much faster. And so we got the internet before we had the intranet. And the same thing could happen now. The consumer use cases could outstrip the enterprise use cases very quickly, especially as agents move to the edge. And I predict that in a couple of years, we'll probably look back and say, wow, all that investment we did in building enterprise use cases have to be rethought because there's so much fragmentation in enterprises because everybody's using kind of their own homebrew solution in this agent chaos. There's a lot of fragmentation, lots of startups, a lot of Series A, Series B companies providing all kinds of solutions. And at some point, hopefully not, but it's possible that one large player has a consumer-facing solution for it, and that becomes the equivalent of HTTP, HTML, URL, and all the stuff we saw in the internet world. And then whatever happens on the World Wide Web actually also becomes the solution that you are forced to use in the intranet because the economies of scale for the internet will start dominating what you would do on the intranet. All right. So I want you to start imagining this world of billions and trillions of agents now, as opposed to thinking of it bottom up, saying, oh, we have like 100 agents, what can we do with it? And now our company is claiming we have 12,000 agents that our employees are creating. As you know, most of them are just BS. They just get created and they disappear when they shut down their computer, right? So I think we have to think about kind of persistent, long-term memory, multi-turn, trustless, crossing silos. It's kind of a very exciting world that's coming at us. And then kind of we're moving through these 3 phases: agent foundations, agent commerce, and agent societies, where in the beginning it's about all the infrastructure, right? Identity, authentication, registries, and so on. But then agentic commerce, agentic societies, and commerce doesn't mean just transactions. It also means there'll be new banks will emerge, new stock exchanges will emerge, and so on. An agentic society, when you move to a city, we don't just get a job and try to survive. We create universities, and we create justice systems, and we create religions, and so on. So the agents are also going to start creating, new societies of this kind. So this may be the most important slide that shows how we're thinking about this at MIT as well as at Project Nanda, which is a nonprofit. The first column is the foundation, and the bottom layer is where you're hearing a lot of noise, which is the syntax layer. A2A, MCP, you guys are getting completely enamored with the syntax conversations. But it doesn't really matter which syntax wins in the end, they're just kind of plug and play, just highly replaceable. So let that battle play out there, and let's see how this plays out. But what will really matter is the layer above that, which is the system and the control plane. And as Danny talked about, some of the ops aspect of it, ML ops, agent ops, and so on. I think that's where a lot of the excitement is going to be. And then, of course, beyond that, there's the global plane. Because again, I want you to start thinking about billions and trillions of agents. So like the global plane at the internet scale, not just at the intranet scale. So everybody's right now stuck in the first column, maybe I would say bottom left of the first column. That's where all the activity is right now. But very quickly, we're moving to the second column, which is agentic commerce. And within that, again, the focus is on like AP2 from Google or X.402, but that's fine. Let them play that out, okay? The layers above that are going to be interesting. What is knowledge pricing? How do you price knowledge? Where is Jules? All the way in the back, right? So if I have to buy like 0.5 kilogram of Jules agent, what does it mean, right? How do I price it? How do I measure it? Can I reuse it for myself and sell it to somebody else, right? There are all these things. That next Groupon is going to emerge where all the agents, will start doing collective bargaining on our behalf. So all these things are going to emerge, and the architecture for that is going to be based on protocols that are going to emerge. But protocols, as I said, are going to be dime a dozen. It doesn't really matter. In the digital revolution, in the SaaS world, protocols really mattered. But in the agentic world, protocols are not going to matter at all, right? And MCP is an example of that where, it's an API plus. You don't really care what the API is. The same thing here. I don't think protocols are going to matter that much. The agents will be smart enough to deal with any protocol that comes their way. And the third column, I'll come back to that at some point. The second is, why do we need an open, neutral agentic web? I think this audience is very savvy. The left is the kind of the diagram we would like to draw in the future. You have consumers and users and enterprise users, and they can talk to anybody else through this, open standards, open protocols, open architectures, open systems, and so on. On the right is how, unfortunately, most of the world is going to usually ends up, which is some kind of a wall garden. You can call it App Store or Play Store or Facebook or Twitter. Pick your favorite, LinkedIn. Pick your favorite wall garden. That's how a lot of enterprises, even a lot of companies, eventually extract value. And hopefully, in the agentic world, we won't get just 2 or 3 agent stores, through which we have to communicate with everybody else, right? That could be very frustrating. It's disintermediation, because some people think, isn't it cool that we'll have some kind of a super agent store or effectively a super app? And if I have to, call my Uber, I can just say, hey, Alexa, hey, Siri, hey, ChatGPT, get me an Uber. Uber shows up in 5 minutes. But Uber doesn't want that, because it's, they would like to show you other cars that are available, or, show you ads or use the data flywheel to improve their services. So nobody wants to be disintermediated. So this is a big risk with closed platforms. And then finally, the opaque algorithms and opaque governance. SEOs are a good example of it. Frustrates everybody when there's so much opacity. So hopefully we won't land up what looks like on the right side. Nevertheless, at the window is closing, right? We think we already have platforms that have hundreds of millions of users, either in AI or AI agents. In the next 6 months, there are going to be intense protocol wars and intense partnership wars. So if you saw that OpenAI or ChatGPT has a deep integration with Walmart, this could be really amazing for consumers. It really reduces the friction, or it could be a beginning of a beautiful wall garden, right? It's possible that the Walmart engineers have only so much time to integrate with one platform and get it right, and they won't really have time to integrate with any other platform, right? So we'll see how that plays out. 6 months after that, companies will use their hundreds of millions of user base and start exploiting the network effect, for very deep wall gardens. And maybe 6 months after that, we have monopolies and duopolies, that create ecosystem locks, service dependencies. Because if you use our tools, and everything will be better. If you use our cloud, things will be 10% faster. If you use our downstream services will be 10% cheaper, and so on by using dependencies. And we have seen this play out in Silicon Valley. So this is not new. And we'll see these monopolies and duopolies emerge. There'll be complete innovation lock. Most investors will lose money because their startups cannot scale. Founders will not be able to scale beyond Series B, maybe Series C. There'll be no company with valuation of more than a few $1 billion. They'll all be subservient to these big platforms. And we don't know which they will be. I mean, I'm not saying this will be OpenAI or Gemini. This will be companies that we don't even know yet, right? I mean, MySpace was displaced by company. MySpace thought they had the game, and Facebook displaced them. And Nokia N95, remember that? Went away in a few years. So don't believe that the current incumbents are the ones that will actually be running this duopolies or oligopolies. It'll be some new player that emerges, maybe in a different country that we don't even know, right? And so we have maybe 18 months to see how this ecosystem emerges. And in 18 months, we could have this monopolies and duopolies. I think it's game over in 18 months. Or we can be on this green line where we have two-way open protocols, and MCP A2 are good examples. Just today, Anthropic announced the AIF Foundation. Who kept track of that? Okay, some of you. So there's some good signs that some of these two-way open protocols are gaining traction. Maybe .orgs emerge, just like NANDA.org, and new ICANN emerges, new Mozilla emerges, new W3C emerges, and so on. And hopefully the long tail wins, right? And then we'll have Pluralism, Adam Smith, Invisible Hand, thriving middle class, and all the good stuff. So we'll see which way we go. So there are a couple of ways we could be on the green line. One is instead of 2 or 3 agent stores emerging, maybe there are 50, maybe 60, maybe 1,000 different agent stores emerge. The Indonesian health system runs their own agent store, and NFL runs agent store for all NFL teams. It's like good fragmentation, but it's in the Goldilocks zone where you don't have millions of different agent stores, but it's also not 3. Somewhere in between would be good, right? And that will force everybody to kind of be nice to each other. Or you could get certain countries, like Estonia has a great digital system, India has a great DPI. So you could imagine some of these countries actually making sure that they don't just believe in sovereign AI, but they also believe in sovereign AI agent ecosystems, okay? Because as I told you, they're moving away from the mainframe era of AI to the edge AI era of AI, where everybody will have their own agent. So one of the projects we're working on in India is actually creating an AI agent for every citizen. And the reason why countries like India and Estonia and UAE and some other places are very exciting is because they already have the digital rails. They have identity systems, they have payment systems, they have bank accounts, all laid out. So it's very easy for entrepreneurs to go and build something on top of that. So the 2 things we're doing in this space, we are creating a horizontal platform, very much like everybody has an identity and a payment solution. So there'll be one layer above that for agents. But then the second thing is which is a platform. But then what you need on top of that is entrepreneurs building solutions. So we'll launch like 1 or 2 startups that build on top of this. So if any of you are interested in talking about this, you don't have to be familiar with India's digital public infrastructure system, that's perfectly fine. But as long as you're interested in building agentic frameworks, come and talk to me to join either the horizontal open source solution or also some of the vertical solutions, because a lot of investors are interested in this. But anybody interested in looking at this? Okay, so yeah, let's talk during the break. The other way to do this is we need a sandbox. Now I'm going to use an example from my hometown where I am from in India, where the next Kumbh Mela takes place in 2027. And this is a great sandbox because you have $2 billion of economic activity that takes place in 30 days. Okay, it's a great time for, if you're like a Series A, Series B player, to go and try these things out. And the government is working with us to figure out, how many of the solutions many of the challenges that you see on the right side, when a lot of people come at one place, need to get solved. So I was just on a call with them, but they're deploying a significant, they're making significant investment to make this happen. Again, a great time for entrepreneurs and investors and also corporates to think about this. So just go to mitcum.org to look at that project. Whole technology stack, we can have a geeky conversation about that as well. And then very briefly, what is Nanda doing about it? So this part of the talk, I'm just giving you an overview. And after the break, I'll talk about some of the nitty-gritties and we'll do a deep dive on that. So what are we doing to create an open ecosystem? So the first, it's important to remember this diagram because when people start thinking about agent frameworks and agent compute and so on, what they mean is the right part of this diagram. But on the left side is the equivalent of the OSS stack of the internet. And this is only partially built right now, and we have to build this out, right? So this is critical. And there's a very bold statement at the top. It says that we are either already are or moving into a post-AI world where intelligence is commoditized and what you do with it is more exciting, right? So just as in the early 90s, we were in a post-PC world. Michael Dell was a very important character back then, but it was not about PCs anymore. It was about how do you connect those pieces. That's why we had Cisco, and that's why we had Norton Antivirus, and that's why we had eBay and Yahoo and Google and so on afterwards, right? It was not about the PC anymore. It's the same thing now. It's not about the AI anymore. It's about how do you connect those AIs, right? That's what the Internet of AI agents. So we think there are 4 choke points that we need to solve to keep it open. And by the way, we're talking just about the phase 1. Remember, the phase 1 was foundations. Second is commerce, and third is society. We're just talking about the phase 1 aspect of it. That the 4 problems we need to solve. The first one is we need the equivalent of the DNS and ICANN going forward, right? So we'll talk about what we're doing there. So, we are actually creating a new ICANN for agents, as ambitious as it may sound. So we encourage you to go to just open neutralagent.org, if everybody can do that right now. And there's a statement there, just sign in if you want to be supportive of this initiative. And there's an open letter that's being passed around with a lot of people who are past ICANN directors, including Esther Dyson, who was the first founding director of ICANN, is also involved. So a lot of great people are involved in making this happen. So if you want to be part of this team, join us. It's a pretty ambitious goal, but it's the first problem that we need to solve. How do we have, how many people here know about ICANN, by the way? ICANN. Okay, pretty good. All right. I was at NeurIPS, which is the big AI conference, till a couple of days ago, and I talked to a lot of people about this. Most of the AI researchers did not know what ICANN is or how DNS works. I thought it's just a generational thing, but I guess in this audience, everybody knows, so that's a good sign. ICANN, in simple words, is like, the telephone book for the whole world. So what we thought is maybe we should actually explain to folks how amazing the telephone system is to start with, that a given telephone can be called by a landline or mobile phone or IP phone. You can be in any country. You can use any phone. Those countries can be subdividing their phone numbers into cities, and blocks, and they can have, once you have a phone number in your building, you can have extensions for that. It's kind of magical. You can use any phone, any carrier, all those telecom carriers can buy any equipment, and I can still call anybody in Nigeria directly right now, with 100 millisecond latency in audio. It's kind of mind blowing. So Mayur and I got together and we thought we should actually write a book about it. So go ahead, Mayur.
We will invite you to scan the QR code. And once you sign in, you'll get the soft launch of the book on your phone.
Yeah, you can download the first 3 chapters already for this. Just scan the QR code. All right. So that's the first choke point, which is the ICANN, DNS, and so on. The second choke point is kind of the portability, right? and certification. So one of the biggest challenges in agents is that, first of all, they have to be verified. They have to be verifiable credentials. They should be authenticated. But the agents build context over time. They build their profile, they build their memory over time, and that memory has to be portable, right? And this is a massive problem because every company is trying to really make sure. There was just a recent code red memo from Sam Altman, and one of the things he talked about was, do the loophole. You heard about the loophole, right? Make sure that the user profile is actually getting used in serving the queries. And OpenAI researchers were reluctant to do that because that leads to addiction, that lead to mental health issues, because it's just being very, psychophancy kind of it kicks in. So OpenAI researchers were reluctant to use the user profile, but turns out people love it when the chatbots remember everything you have done so far. So anyway, that issue aside, making sure that the memory and the context of an agent is highly portable is not an easy problem to solve, right? Because the efficiency of the system makes it nearly impossible to do that, but we have to strive hard. If for my personal agent, if I'm a booking.com, if I'm a Citibank, if I'm a hospital, if I'm a social networking, my work profile, all those things right now are fragmented. But if Ramesh agent has to do a good job, then all these profiles have to be together, right? And I have to be portable wherever I go. So this is a very interesting challenge. We think this has to be solved. The third one is interoperability, which is obvious. And the fourth one is the notion of universal attestation. And I'll talk a little bit more about that, which is you want some kind of a crash test, and test tracks. Danny talked a little bit about, various ways to create simulation environments in MLFlow, but there are many other, that's very important, but there are many other scenarios that you need to be exposed to. So if you have time later on, I'll show you a live demo on how this is done. So if you can solve these 4 choke points, then we can float slightly above, the rat race of protocol and protocol wars, and actually start making, the agentic world a better place. All right.
Ramesh, just one point.
Yes.
So you mentioned authentication.
Right.
The authorization or the ACLs for agent.
Right.
Which I want to be separate from what I can do most of the time.
Right.
That's also as critical. I assume you could kind of mend it somewhere.
Yeah.
That's also a very critical point.
Absolutely. So this slide, right? So I think the next question is, how are we going to tame this agent chaos, right? So first of all, the agents are getting written with bytecode. What could happen, right? So I'm actually very excited because 20 years from now, or even 5 years from now, people are going to start calling me Ramesh. You actually know how to code? Instead of just writing prompts, can you come help us? It's like those people who were called back for COBOL during Y2K. I think we'll be called for the Y30K, for 2030. That's my guess. So there's a lot going on. I think we're going to get the technical debt for the agentic web, the agentic enterprise is going to grow so rapidly, and unless a technical debt where the people who created the debt sometimes go and fix those problems. Here we won't even have the same people because the technical debt is created by your cursor, your replit, and so on, right? So there's going to be a very chaotic world that we're going to live in. So governance, routers, observability, there's a lot going on, and I would imagine there'll be a startup in each of these bubbles, that has to emerge to see how we can do that. So for all of you in this audience, thinking about what do you want to solve in agents, please do not create another agent framework. Okay, there are a lot of problems to solve here. All right. So finally, I'm going to just walk you through very briefly through a few case studies of how other people are either using NANDA platform or inspiring us to do that. The very first one is my friend Jim Ryan, who is working on AI safety. And what they told us is that there's new toys coming for Christmas, like teddy bears and robots and so on, and they have ChatGPT inside them. They're only like $100, by the way. So your child can talk to this toy with ChatGPT, verbal. What could go wrong, right? So, inappropriate content, addiction, long-term dependence, reinforcement of, self-harm behavior, and so on. By the way, this is already happening just in the last 2 weeks. This article in New York Times, and just in the last 2 weeks, 2 different players have withdrawn their products from the market because the toys were kind of giving a lot of, sexual, conversations. Very easy to break. But these are $100 toys. These companies have no time to go and make sure that the guardrails are working and all the good stuff that you heard from Danny. They don't have time to do that, right? So there's a rapid rise on all these kind of consumer-facing solutions. Children, obviously, this is the first thing we want to solve, and so we are working on, creating a sandbox, a test track, a crash tests for doing all of this. But it's not just before you release the toy. The problem is you have to do this while the kid is using the toy on a daily basis. It's like every year you have to get, your car inspected. We expect every week, maybe, the toy has to be probed to see what is going on. A very exciting project. If anyone wants to come join us, it's a massive effort that's going on. The second is Robert Bench from Radius. And one of the problems they're solving on is micropayments for agent-to-agent transactions. And there's a very beautiful chart that Robert has created. On the x-axis is the average payment size, anywhere from, like few cents to, tens of thousands of dollars. And the vertical axis is the daily settlement volume, right? And if you look at this, you would imagine that there are solutions today to do microtransactions down to like half a cent or 1 cent, but nothing like that exists right now, right? So even stable coins don't solve that problem. There's a whole spectrum of issues that need to be solved. And then, feel free to go to Radius and how they have used NANDA solutions to build something. The next one is Karan Bharadwaj, and he's working on an open source platform for agent ops, right? And maybe Danny, I should introduce you to Karan as well. And they are inviting groups of enterprises, groups of startups to work together to build out this agent ops framework. So just scan the QR code if you're interested, and they'll have their open source solution. He said he'll be deployed in the next few days, coming together. So feel free to reach out to Karan if you're interested in open source agent ops. Also, Abhishek at Tresata, and they are working on. Does anyone know about agent cards for A2A and so on? Anybody familiar? Okay, some of you. So I'll show you a live demo. So when agents have their own agent cards, agent facts, we call it agent passports, and there are many, many fields within that. One field that's missing is actually the data itself, because right now the assumption is that the context for agents is sufficiently small. But what if it's the size of what Databricks does? Like, what if the context for agents is terabyte of data, right? That is accumulating over time. What would you do about that? So Abhishek and his Sunicorn, he tells me, Tresata, is working on a platform called NANDini, which is a play on Nanda. His daughter's name is NANDini, by the way. And they're creating this agent passbooks, right? Not just agent cards, but agent passbooks and data coordination protocols and so on. So look at how we're working together with them. So to conclude, go to projectnanda.org. I believe the left QR code is the WhatsApp group for the Bay Area chapter, and the right QR code is for the LinkedIn page for the Bay Area chapter for Agentic Web. So just take a picture for the whole thing, and you can look at that later. So yeah, that's Project Nanda. 3-phase research roadmaps. A lot of work happens at MIT and academic settings with different organizations, code-based collectives, regional chapters, fellows program. We have a fellowship if you want to apply for a paid role for contributing to open source there. Write papers with us. I believe Youth Council. If your kid or nephew or nieces want to work on Agentic Web, and so on. And I believe we have Mahesh somewhere here, right? This is Mahesh. So Mahesh is also leading our research efforts. So please come and don't let the Stanford logo get in the way when the MIT guy is standing right here. We'll figure this out. But yeah, so he's at Stanford. So he's also leading some of the research here. So I think there's, we have to kind of change our mental model of what we mean by agentic web that's powered by edge AI and tiny ML. And the group thing on centralized AI, I think we should see if the group think is wrong. And I think we have to approach the agentic web not like building intercoms, because a lot of times when the enterprise is building agentic solutions, there is an administrative dashboard to click, 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 and connect agents. That's like building an intercom, but we actually build a telephone system. But nevertheless, the window to keep the agentic web open is closing, maybe 18 months. Thank you.
Thank you. So we're going to have both the speakers come up front to do the Q&A because we didn't have a chance to talk about Q&A for Danny. So Danny, why don't you come over and we're going to open the floor with a question. I know you gentlemen had a question about MLFlow and I told you, so I'll give you the mic.
If I have time later on, I'll show the demos and what the developers can do and things like that. But let's get going.
Yes, thank you. Actually, I think I'm going to change my question to based on the previous talk. I'm wondering if you could say more about what lessons we can learn from previous kind of efforts to create the walled gardens with IBM and Microsoft and sort of the rise of open source software in the past, and how we can kind of use those moving forward to create the vision that you were speaking about for the open agentic web.
Yeah, I mean, as I said, we have 18 months to a complete lock, and the chance that we can keep it open is very, very small, right? Because there are companies with trillion-dollar valuations, either here or other parts of the world, that are going to constantly, unintentionally, not intentionally, but unintentionally end up building walled gardens. So it's a massive challenge. I think the good news is that so far, if you look at what's happening in A2A and MCP and X.402 and so on, things are relatively open. But one bad quarter or one another code red memo and everything will change, right? And people will kind of lock in and get that going. I think you're asking me about what happened in the 90s because I'm the older of the two here. But you should read the book called How the Internet Happened. It's a fascinating book by I think Brian McLeod, who also has a podcast, and he just lays out chapter by chapter. The war between Netscape and Internet Explorer, and war between iPod and what was it called back then?
Pilot.
Sorry?
Pilot.
Palm Pilot was well before that, and so on. So I think there are a lot of lessons there. And if you just compare the World Wide Web versus mobile OS versus social media, I think the good thing that happened during World Wide Web is, as I said, there are a bunch of organizations that emerged. Mozilla, ICANN, W3C. Nothing like that emerged for mobile OS. Nothing like that emerged for social media. And that's why we are grappling with those walled gardens and their societal impact and lack of innovation. I mean, it's impossible for developers to do something on social media platforms, right? You cannot tap into that amazing societal movement and technological movement. And it's not a multi-trillion-dollar industry either. So it's kind of a lose-lose, I mean, if you look at this curve, the other way to look at this curve is, are we going to have, a multi-trillion-dollar economy because of AI agents, or are we going to cap ourselves because it remains a walled garden? So I know I'm not giving a complete answer, but some of the ways we are solving it about it is like working with places that have 1 billion people who have DPIs and they can launch their agents overnight.
Any other questions?
Thoughts on that?
Yeah, I have a question.
Okay. Danny, did you have a thought that you want to complete?
Yeah, I think just what I think is currently interesting is people are, I think to your point, like it's relatively open. I think at least what companies and consumers and customers can do is like everyone is kind of relatively building it open as well. People are building on open source that they're kind of fairly scared about locking into any individual vendor. And I think that's a good thing. Really, I think a lot of the stuff that we're working on is also about how do you promote that kind of like interoperability so you don't feel like you need to use like a particular framework or a particular solution. So I think that's at least what we can do to kind of promote that open ecosystem.
So you are in favor of the green curve?
I have a personal take, and there's probably a separate Databricks take.
He has a purple curve.
Thank you, host and professor. Have a wonderful presentation. My name is Heidi. I'm writer. Interesting. I was Henry reading some AI book. So my question about can you share more about your reading this is AI book experience and something good idea? Thank you.
You said experience writing the book?
Oh yeah. You're reading this book.
Yeah.
We reading this is
Yeah, maybe during the social you can talk to my ear. Yeah.
Any other questions?
Hello. Yeah. Thank you for the talk, both of you. First question to Professor. For all of this to work, we are very much thinking that everybody will be able to host their own agents. If that's true, how does the energy consumption work? And like this is not something that you can easily tap into. So how does that? Is that something that you're concerned about? And is that something that you see a direction, you see research that kind of, makes that happen?
I mean, if you have a PC or a laptop or an on-prem solution, it won't be running models will not be more, compute intensive than like playing a video game or something like that, with a bunch of GPUs. So, there'll be sub-billion parameter models, and they won't like a given model will do only one thing. It'll say, hey, I'm a dentist and I want a solution to run my dental operations, or I'm a lawyer and I just want things from a law firm. The agent that does work for a law firm doesn't need to know the theory of relativity, and so on. So you'll have these highly distilled models that do things that you care about. And then if you do need other things, so let's think of it this way, right? What is happening in the so-called AGI world? I think AGI is kind of gone. Nobody worries about it anymore. They're worried about making money. But they gave up on AGI world because they said they hit the wall on pre-training. Then we said, oh, it's all about post-training, right? And then we said, oh, actually, it's not even post-training. It's about reasoning because it's not training time compute. It's all about inference time compute. It's like, okay, that's interesting. Then they say, actually, it's not inference time compute. What we should really do is, these are very dense models. What we should do is like MOEs. We should do mixture of experts, because they can't be too dense. So let's start creating like 16 or 64, whatever, different experts and start doing that. What's going on, right? So basically what we're saying is it's better to have 64 different models, in simple words, than one model, right? Now, they're not calling it a health model and a law model and accounting model. They don't have labels for it, and they're not completely orthogonal to each other, but that's where it's happening. So instead of 64 models running on a single machine, maybe 64 models should be spread out across 64 different geographies, right? It's the same thing. So I think even the research in machine learning is actually going in that direction anyway, where it makes more sense to distribute, your intelligence, either in one machine or multiple locations. But now once you have, 1 billion different experts, the mixture of those experts is going to be so much better than having 16 or 64 or 256 agents, 264 experts running in one place. Because not only those billion agents are going to cover more ground, but those billion agents have access to local context, local knowledge, and local innovation. That's embedded in those experts or those agents. And the third, the emergent behavior coming from those billions of agents will easily dwarf anything that's going to happen in one kind of a data center, even if it's powered by nuclear power plants.
I mean, the other thing would be the supply and demand for all these chips. Do you think that with all these major players trying to acquire as much as they can, there's even a possibility that everybody even gets one GPU to work on or run their stuff on?
Remember, if you look at the amazing innovation that's going on in China, they are actually not dependent on GPUs, because a lot of these MOEs actually are sparse, and they're very compatible with CPUs or low-end GPUs as well. So we should really thank the Chinese innovation, because it's showing a completely different path going forward. And this is not what NVIDIA would like, right? Because GPUs are very good for dense calculations, dense graphs. So there's a very interesting dynamics that's going on. I encourage you to read up on the Quen models and so on. They have a very different philosophy than some
So
of the
much
models
for the
that's in here.
answer. One question to Danny.
But Danny, you have some thoughts on that?
No, not anything particularly insightful to bring to the table. So
He's being politically correct. He's like, I'm not going to short my stock. Ramesh, I just this morning, by the way, I called my advisor and I sold most of my AI stock.
yeah, but I will say I feel like we are still seeing a lot of the improvements from distillation, working on smaller models. I think I even called out in the talk, people are still beginning to move more and more towards even at least in the enterprise, more enterprise domain specific agents that don't really need all the computing power as well. So I think that is a trend that we are seeing.
Can you give us a ballpark? Are you when we start doing distilled or of course there are also off the shelf small models.
Yeah.
Are they, just give us a ballpark number? Is it 100 the power, 100 the cost? What's the ballpark you would give?
I mean, I think it is kind of multiple orders of magnitude smaller.
Right.
So I think we were even able to one experiment we did was we took GPT-4o mini and compared that to GPT, I think it was 5 or 4, or maybe it was 4o, and we were able to get much better performance with 4o mini if we just tuned the right kind of prompts. So it's definitely possible. And I think we saw that also previously with just the original LLM kind of space as well, right? You go really, really far by distilling LLMs. So
yeah, and which is very true. And also it's good to remember that even if the absolute parameter numbers is not sub 10 billion, so some of the US models are sub 10 billion, which we call small models. There could be a 60 billion parameter model, but it only loads in the memory, a couple of billion parameters because of MOE. So that's perfectly fine. It just sits on the disk.
I had a quick question for Danny. I think something that he actually showed in the demo. Danny, when you were actually showing the demo to include the human feedback that this gentleman asked you, how does the human feedback gets incorporated? What's the next step? What happens when you looked at the trace and you say, here's the feedback that I want to give to the human? How does that feedback get back into the training or in the next version of the prompt?
Yeah, so I guess there's the manual way to do it, which is you just use the MLFlow UI to look into it. I'd say a lot of what we're thinking about is actually how do you automatically incorporate that. That was kind of where that either automatic optimization kind of comes in, or if it's in the context of a judge, we have automatic judge alignment as well, which also can kind of take agentically what are all these feedbacks they're getting and improve it. So yeah, I think our philosophy is move more and more towards that automated flow.
Which is more scalable compared to each and every.
More scalable,
Yes.
That's right.
Yes, thank you.
Yeah.
We got a question over here.
My question is to both of you guys. So essentially, agents now mostly communicate in natural language, but papers and works have shown that, hey, if you gain access to this output, even if it doesn't say let's output a PI, you can still infer the PI in the input. Essentially, it's very easy to mount membership inference attacks on the output from the agents. And then other people are also looking at, okay, what if they communicate in hidden states? You still get much better, easier communication, utility is higher, but then you lose all sort of explanation. You don't know what the agents are talking about anymore. It goes fully black box. We don't know how membership inference works on the hidden states, but then I would assume higher than natural language. So what's your take upon, especially Prof. Raskar, when it comes to building the internet of agents? How do you think agents should communicate? Should be in natural language? How do we maintain no leakage to PI? Is differential privacy a solution? Or do you think we should move to hidden states because the utility is there?
a complete agent chaos, as we said. Actually, I want to hear Danny's opinion because, I mean, part of MLFlow is actually about looking at prompt injection and, he's talking about membership inference. You know that problem, right?
I'm actually not as, I mean,
So membership
I
attack
know-
is like you try to figure out what were the data points in your training data sets.
So no, essentially
Yeah.
that's for like memorization, but then you can do it at inference time too. So it would look like, hey, if I see this output from the LLM, can I predict what PI was used in the input? So that would be membership inference in the input.
yep.
They're super recent. In fact, we show in our paper too. You can have success rates of over 60% in doing this kind of an MIA. It's like really blowing up now.
And Danny, if you can expand on the question, does it get worse when you have workflows and chains of agents? Because I would imagine, a couple of percentage leakage in every agent could kind of cascade over time. So
Yeah, I mean, I feel like so these are just like me talking, like totally off the cuff, but at least like previously when I had done work in the space, a lot of like, specifically like related to like differential privacy and whatnot, a lot of it is about how to use like random noise to kind of obfuscate it. And like, can you measure out how frequently does something need to show up in order for it to actually like kind of leak? So I feel like agents right now introduce enough noise anyways that it might, I'm kind of optimistic that like the more, I think that we're moving in the state where like to actually build your highest stakes use cases, you need fairly complex agents with a lot of workflows and sequences. And with that, you have so much information loss at each step that you end up kind of obfuscating a lot of the interesting information. But that's kind of an optimistic take. I think you'll still need to have like guardrails in the middle to kind of actually like special purpose built guardrails in the middle to really prevent that. But I don't have like specifically on membership inference that I don't really have good takes on, I think. Yeah.
But I do agree with you that the problem is more likely in smaller models than larger models for
Yes, for sure.
sure. And I mean, you're a researcher, so would love to kind of see you plot on one dimension is the model size, other dimension is the
But
leakage.
Professor, so far doesn't seem to be a function of the model size. In fact, so membership inference you can bound any, you can mount on, let's say from 1 billion to let's say 100 billion, doesn't matter. The ASR is the same around. But coming back to what Danny mentioned about, let's say complexity and then that sort of reducing the ASR, that we don't see that. So it turns out, because at the end you're just building this context when you're doing inference with an agent.
But I would imagine with inference time compute and if models are using either LoRa or RAG, I would imagine they'll leak more than if that's something that's.
I mean, the experiments we ran was like in a basic single inference setting, and then it is a function of the number of tokens you generate.
Right.
But then we don't know. Let's say if you're doing, let's say, a quantization, how does that affect leakage? But the leakage is there, and it's a big number. But then, and coming back to what Danny said, hey, you can have all this obfuscation because you're building context and stuff like that. As long as the PI is in the context, you should be able to infer it. So you need, let's say, differential privacy. But then my guess is we'll move communication to hidden states because it's like the utility is crazy on that.
I mean, I think there was a nice Microsoft paper recently where they showed that agent communication that's purely in the representation space and the embedding space was actually quite convenient and more efficient.
Yes. Because now you don't have to say, let's say, share 10,000 tokens. You can do a vector of size 768.
Yeah.
It carries all information.
It makes
so
sense.
I think everyone's going to do that.
I mean, natural language is more for explainability, like you said.
Yeah.
And it'll probably will get eliminated as we start building the agentic workflows.
Thank you so much, Professor and Daniel.
Are you seeing that, by the way? Are people using different handshakes in the agentic workflows rather than using traditional,
I'd say people are mostly using existing APIs, and APIs are often built for humans. So it is very much kind of like still kind of a very inefficient communication mechanism.
big JSON payloads and so on.
Big JSON payloads, yeah, exactly.
We got a question, Patricia here.
Professor, in your description of the agentic web, you have the foundations, the agentic economy, and the agentic society. And right below, you have population models.
Right.
Do you refer as agentic-based the role of sociology, philosophy? Is that what you're referring to?
I mean, I'm not an expert, but recently we just published some work where we said that if you want to predict, if you want to model, not predict, if you want to model the impact of any emerging technology on US population, how would you do that? So we created 151 million agents corresponding to every US worker. And it's amazing. The Bureau of Labor Statistics, the census has data all the way down to a block level. Okay, like literally block level. Education, employment, all the stuff, right? Race, gender, all that is available down to a block level, aggregate down to a block level. And so we can take that and instantiate, as I said, 151 million agents. And for each of them, the Bureau of Labor Statistics also takes every job. I believe there are about, I forget the numbers, but like 30,000 types of different jobs. And for each of the jobs, what the skills are, right? And we can map out all of that, create a sim city where this 151 million agents are interacting with each other based on their geographic location. So, of course, a salesman might travel 10 miles, but a janitor might only travel 1 mile, whatever that statistics is, and so on. So we do all of that, and it runs on supercomputers at the Oak Ridge National Lab, okay, for free for us from MIT. And from that, we can model population level effects. Because if you think about today's AI models, they're almost like a personal AI, right? Because I send a query, I get an answer, but it doesn't look at what if thousands, maybe millions of people are doing something with the system. How do you get aggregate effects? So a lot of our research is actually on this, large population models, LPM as opposed to LLMs. And it's a very fascinating topic. And of course, there are new startups now that are using this kind of mechanisms to predict how to do surveys, customer surveys. I think, Danny, you were telling me earlier that they're using this kind of simulated agents to, what did it say? To do just.
This is, we're building kind of simulated agents to simulate conversations. So you have an existing agent, you want to improve it. Right. But once you improve it, then the conversation probably will take a different fork.
Yeah.
So then how do you build kind of agents to simulate different percentages of users to actually evaluate, is your improvement actually better?
Yeah.
Yeah.
So I think that's like a fascinating field that's emerging out there. And I mean, I'm guessing that this gives you like a first cut, doesn't give you the final answer, but gives you the first cut or what could be going wrong, going right. And then you have to dig deeper to understand that. So just a fascinating field. Again, I'm not an expert in sociology or anthropology and so on.
Should we take 2 more questions? Right. Gentleman over there.
Behind you.
Well, we'll take the 2 questions and then we'll end because these guys are here for another half an hour, so you can query them and corner them and ask them whatever you want. So go ahead. You got the mic, yeah. Don't drop it.
First of all, thank you for hosting. This was very enlightening and very, I'd say these aren't topics that are covered a lot in other venues that we go to or I go to. So thank you for going through this. And my question was, do you envision a world where every interaction with a quote unquote agent is pre-baked, meaning there's an agent that does XYZ versus something more ephemeral, like I go to the agentic web and as I have a need for something, an agent is spun up. So in the sense that the agentic web itself is like a kind of a, not to overuse the word, but kind of like an AGI in the sense that there is an overarching intelligence. And then as human users interact with that, a component of it is kind of distilled in real time almost, does an action and then goes back into like the main. That's one way of thinking about it.
If I can rephrase your question, it's like, is it inside looking out or outside looking in? Which is like, am I going to carry my own agent that goes and interacts on my behalf? Or other people are going to run my agents and, they're looking at me, right? Like today we live in an outside looking in world because, my social profile, my bank profile, my health profile, my travel profile, all of that is owned by somebody else, and they have to interact with them. So it's kind of an outside looking in. And it's frustrating because I cannot connect my travel profile with my bank profile, with my health profile and so on, right? So I had to kind of copy paste things from here and there. And that's why these browser agents are kind of coming together, because they try to do like a kludgy job of connecting different profiles that you have online. I don't know which way it'll go. I think the dream is everybody has their own agent, and we kind of create our own profile. And as I said, your memory and your context is highly portable. That's the dream. It's quite likely that LinkedIn tomorrow just launches an agent for everybody. You log in and LinkedIn has an agent for you. And if they're smart, they would just make that kind of center of the world for every enterprise, for every economically viable, because then your job is basically listed on LinkedIn, and they could just take over the whole world if they want. Hopefully we can do the other way around.
Yeah, I actually feel like the current trend is in the opposite direction, which is it's very hard to build an agent today to kind of solve a particular task, even with a lot of effort. And I think the larger companies are also kind of realizing that you can't just build one big model to solve everything. So it is kind of moving more and more towards like build more specialized agents. And human in the loop is always like super, super critical at this point. So unless there's like a huge technological breakthrough, I actually feel like it's more likely that we're going to land in this kind of golden state of there's a lot of smaller agents purpose built that you're going to query, rather than just like some random new like inference time agents training thing that self builds itself. Seems like a fairly far distant future.
Yeah.
When you say about purpose build, are you talking about the MOE model where you have multiple agents who are special experts?
Kind of. I feel like it's a very loose MOE
term,
that we're
okay.
talking about here.
Okay.
Like MOE, I feel like you're still training for some objectives, whereas in this case, it's like each person has their own kind of agent that you're building, but that is like a distinct objective that you're optimizing for, right?
He meant mess of experts.
Mix of experts.
Mess of experts.
Mess of experts.
Yes.
Yeah. Chaos of experts, you speak. using Ramesh's term. Okay, we'll take the last question over here, and then we'll call it a day.
Thank you. So far, I mean, the consumer has been logged in with the phones, with the App Store, right? So with the new agents in the picture, do you see a new wave of hardware devices? So where you can completely decouple the App Store, the end users?
I want to hear Danny's thoughts. I think the whole stack is going to get reinvented. Just like in the 90s, I mean, we all had dial-up modem. At least those of us who were there, had dial-up modem. But when we moved to broadband, everything shifted. And I think the same thing now. I think we are kind of in the dial-up modem phase right now, because there are mainframes sitting out there, and we take dumb browsers and talk to those mainframes, through command line. That's all going to change, right? So I think hardware, the UX, the chips, local meshes, local networks, of course, multimodal is a given. Ability to find the right agent that you can work with, like your Rolodex, it's going to become very critical. Which agent is going to become very critical. The Yelp of agents, like the whole stack is probably going to get reinvented. And it's possible that, the World Wide Web was supposed to be decentralized. In fact, W3C was very against any centralized listing. But then Yahoo came, and then Alta Vista came, and Google effectively re-centralized the web, right? They're like, okay, this is what you mean. This is where all the information is. So, even their motto is like, let's just re-centralize the web. And now it's unclear how it will play out. I think we thought it'll be a decentralized agentic web, but it could get re-centralized, right? It could have only 2 app stores, 2 agent stores that are out there. But as Danny said, I think getting it right is so challenging that hopefully we'll have a lot of fragmentation in the beginning. And that's a good opportunity for entrepreneurs.
Yeah, well, I feel like the individual agents are going to be hard to build for like any given company. But the app store argument, I think, is interesting, because I feel like in part why mobile app stores kind of became a thing was there is like a discoverability component to it that wasn't available outside of the kind of closed wall. And on top of that, why I started having perversive effects is because there's a financial incentive. Like now you have like recommendation systems to recommend different apps. Now it becomes just like this like big kind of mess. So yeah, I'm curious kind of how that's going to play out, because there's going to be some short-term incentives for the developers to say, let me find the fastest way to build my agent. And that's probably going to be going through one of these like, random app stores. And how do you kind of counteract that? I'm actually very curious on how we can build that kind of ecosystem.
Well, thank you very much. Give a big hand to Professor Ramesh and Danny for giving us insight. I think we are pretty much closed today, but you guys are ready to hang out for another 15 to 20 minutes before the janitors come and kick us out. I think Ramesh, you wanted to show something?
I just want to flash.